Hi everyone. Welcome to BrainCandy Labs. I'm Ava Astro. This is our very first kids conference. Our session today is from building organs to zapping brains, my nonlinear path through science with Jordan Harrod. First, some housekeeping. I invite you to turn on your cameras if you wish to get up close and personal with your speaker. Please turn it on. I really want to see all your faces. You can switch your view from gallery view to speaker view at the top of your screen. All lines are muted. Don't get too much background noise. As our speaker shares with you, you'll probably have questions. That's great. Put them in the chat and she'll get to it in a later section. Now let's get to know our speaker, Jordan Harrod. Jordan is a PhD student in medical engineering and metaphysics at Harvard, MIT. Health Sciences and Technology program. Her research focuses on the intersection of non-invasive brain-machine interfaces and deep learning for clinical pain and anesthesia. In her spare time, she loves to engage in science communication, science policy advocacy, and writing. You can primarily find her on your YouTube channel, where she discusses how artificial intelligence and algorithms impact our everyday lives. Jordan, on to you.
Thanks for having me. I'm so excited to talk to all of you guys today. I wish I'd known that there were conferences like this when I was your age, because it probably would have helped me navigate some of the situations that I'm going to talk about today. In particular, I think it would have helped me realize that the winding path that I took through science is completely normal, and that just because you planned for a certain job or career doesn't mean that you can't change your mind at any point. And that applies to things outside of science. If you think that you might be into the humanities or that you're into art, it might not be a straight path to figuring out what you like now and what you might like in the future. So to spoil the ending a little bit, the two main pieces of advice that I have for all of you and for myself about 10 years ago when I was 13, are that first, if you have the opportunity to try something that you think that you're interested in, whether it be music summer camp or an online coding class, then you should definitely try it. You might love it, you might find out that it's not quite as interesting as you thought it was going to be, but either way, you're gonna learn something about yourself, and it's gonna help you figure out what you might wanna do next. My second piece of advice kind of jumps off that, and it's that if you try something and you don't like it, put it on an imaginary shelf and maybe come back to it a little bit later. I've personally found that a lot of the things that I didn't like are things that I enjoyed in terms of the project, but maybe didn't enjoy the circumstances or the people or something else about that situation. So maybe I had to get up too early in the morning. I used to sing in choir, but I had to be up at 5 a.m. to be at school by 7, which wasn't the most fun. Or maybe I didn't like working on one part of a project, but I would have really liked working on another one. And I know that's a bit vague, so I'll get started with telling you guys about all of the things that I tried to get to where I am today. And hopefully my journey and my experiences will make that a little bit clearer. So for the youngest of you watching, when I was 8, I wanted to be a teacher. This is probably because my mom was an English teacher and I loved reading books, so the idea that I could just read books all the time and talk about them with other people sounded great. However, after spending some time with my mom and seeing how much time she had to spend in the classroom as well as outside of the classroom when she wasn't supposed to be at work doing work, I started setting my sights elsewhere. I had discovered an interest in math, and more specifically in problem solving. In fact, it's one of the only subjects that could really hold my attention for long periods of time. I actually hadn't discovered my interest in science yet. As many of you have probably experienced going to school, science in elementary and middle school often involves a lot of memorizing facts and charts, and that didn't seem super interesting to me at the time. So around 10, I decided that I wanted to be a doctor. I think everyone goes through this phase, but my interest in being a doctor ultimately came from my interest in math, actually. Treating patients seemed like the ultimate problem-solving exercise, plus you actually got to help people, which was pretty cool. I stuck with this plan through early high school until I was about 14. But there was one issue that kind of nagged at me the whole time. You see, I've always been a little bit absent-minded. My parents would tell me to do something and it would go in one ear and out the other, unless they really made sure that I was paying attention or left a note or something somewhere to make sure that I saw it. We didn't know this at the time, and in fact, we didn't really know this until about 6 months ago, but I had ADHD. And while I didn't know what to do about it, I did know that being an absent-minded doctor seemed like a bad idea. After all, what if I hurt someone? So I started looking for ways that I could solve problems in medicine without being a doctor. And you might think that that would lead me to where I am today, where I study biomedical engineering, otherwise known as medical engineering and medical physics. But I'd actually already decided that engineering wasn't for me. You see that I'd spent a year on my middle school's robotics team, and it turned out that I just didn't like robotics. Too much public speaking and making PowerPoints, so clearly I couldn't be an engineer. Now, we'll jump back into my journey in a second, but robotics is actually a great example of where my second piece of advice comes in. I thought that I didn't like robotics I thought that I didn't like engineering because I didn't like robotics. But what I actually didn't enjoy was that the girls on the robotics team had to make the presentations and talk to the judges, and the boys got to actually design the robot. So if I'd gotten the chance to work on the robot, who knows what I would be doing right now. In fact, I only rediscovered my interest in robotics and circuits in the last couple of years once I got the chance to build them myself in college. So if I couldn't be an engineer, then what else could I be? Well, I'd been watching this show called Bones at the time, which none of you have probably seen because it's now an old show. And one of the main characters had a job called being a forensic anthropologist. They studied murder victims to figure out how they died and solved crimes with the FBI. And that seemed perfect. After all, there was no risk of harming the patient since they were already dead, but I'd still get to do a lot of problem solving. However, it turns out that's not really a job. And that also applies to a lot of careers that you see on TV. Just FYI, that was not something that I realized until high school and I had to start looking into it. Instead, being a forensic anthropologist is really called being a mortician. And it involves mostly working alone in the basement of medical facilities, usually not on crime. So it didn't seem as interesting to me anymore. But at that point, I was also a little bit lost. I mean, what else could I be? I'd also been dealing with some health issues at the time. If you're familiar with diabetes, I had something similar to that. And I'd seen a show on PBS about making organs that could treat diabetes in a lab. So that sounded pretty cool. So I looked into it and I found that it was a field called tissue engineering. Diving further into shows and articles on the topic, it sounded like you could build a whole new human being in a lab. And this introduced me to biomedical engineering and also introduced me to the idea of research, which at the time I thought was doing a lot of Googling and then writing up a paper about what you found and submitting that. In fact, I'd actually done a research paper in middle school on the Twilight series where the only 4 citations I had were the 4 books. So I was very lucky to have the opportunity to try biomedical engineering and to try research in a local lab. And I really enjoyed it. I think that in high school, it's a great time to start getting involved in research if you have the opportunity to do that. And so when I went to college, I thought that I would make organs and use them to help people. In fact, I had a particular lab in mind going into college, and it turned out that they didn't actually need help on that project, which is also something that you'll have to adapt to. Instead, they put me on a different project, focusing on engineering the meniscus, which is in your knee. It's the thing that people often tear when they play soccer or play football. And so it's something that we see a lot of people come into hospitals with, but haven't fully figured out how to deal with in a way that treats you for the long term. So I could talk for hours about what that project taught me. But the main thing that it taught me was that I wasn't actually interested in making organs. It turns out that organs require you to work with cells, and cells are very finicky. They only like living in certain conditions, and if you take them out of those conditions, then they don't react well, and they're not very happy with you. Instead, I actually found that coding, medical engineering, and electrical engineering really captured my interest. And I was lucky to work with a professor on that new project who let me pursue those interests. So I got to take our samples down to the MRI facility and look at the images that came out of that and analyze them with code. I had a grad student who pushed me outside of my comfort zone frequently by making me learn new coding languages in order to solve different projects. And so this is actually how I found machine learning or artificial intelligence, which is a specific kind of coding that you've probably heard a little bit about before, but it's where we develop programs that learn from our data and then use it to predict on new data. And so like all the other things I tried, I thought this was interesting. And so I spent 2 summers, 2 separate summers, one working on data science specifically, and then one working on machine learning. So the first project was because that I thought that I was going to go into the drug industry. I thought that I was going to make drugs for people. And I spent a summer there, and it turned out that I really didn't like working at a company. The main reason for this is because I found that, at least at that company, you got projects that were associated with different tasks that needed to be done, but you never really got one project that was kind of yours. There were a lot of things that passed through your desk that you just had to do, and you didn't get to find out what happened in the end. So you might analyze a data set of fluid that's in people's eyes and see whether or not a treatment's working or not working, but you don't get to find out what happens next. And one of the things that I really love about research is finding out what happens next. So I decided that I didn't necessarily want to go into the pharmaceutical industry. For the machine learning project, I spent a summer working on that. And that's a fun story where I didn't know that I would be doing machine learning until about 2 weeks beforehand, and I had no experience with it beforehand, so I had to learn it on the fly. And like robotics, I left that project believing that machine learning was not for me, and that I would never do it again. In hindsight, it turned out that I did actually enjoy machine learning, and what I didn't so much enjoy was that my lab for that summer was all about working from home. And so I was lonely. I didn't have anyone to spend time with during the day or to talk to. I didn't have a ton of guidance on the project that I was working on, and I just didn't fully understand what to do. So I since found more resources and people to learn from, especially now that I'm in grad school, to the point where I now use machine learning pretty much every day in my research, and make educational videos on YouTube about it. Speaking of YouTube, I rediscovered my interest in teaching in college as well. It turned out mostly that I am most interested in teaching topics that I enjoy learning about. And so I taught a class on engineering superheroes using biomedical engineering, and had a lot of fun doing that. And switched to YouTube mostly because I was just interested in learning a new kind of science communication, something that doesn't rely on the classroom quite as much. So now I'm in grad school. If you don't know, grad school is extra school for people who really like school. It's kind of nice because instead of paying to go to school like you do for college, I get paid to go to school. And at the end of it, I will get my PhD, which means that you can call me doctor, but I cannot treat your medical concerns. So now I get to make devices that zap your brain in order to help treat pain and replicate anesthesia, which is the thing that you go under when you go in surgery that makes you like pass out and not feel pain. And I'm also looking at coding to control the devices to make sure that, you know, you go under as you should, you don't feel pain as you should, and then you come out as you should, as well as to analyze a bunch of fun data that my labs let me play with, which is great. So yeah, my main takeaways from this are that whatever you think you want to do, definitely try it. There's so many things, as I mentioned, that I tried that I either didn't think I was going to be interested in or didn't realize what really went into the day-to-day work on projects like that. So organs or something like that, where I didn't quite realize what goes into developing those systems. And so it turned out that that just wasn't particularly interesting to me. And so it might turn out that you like it, or it might turn out that you don't. And either way, that's okay, and it's just something to learn from. But again, try to understand what it is that you didn't like in those situations, or what you did like, because it's really helpful to inform what you might do next. And it can help you figure out what other resources you might look to or what other people you might look to get you to your next step. So with that, I can take any questions, and I see that there are some in the chat.
Yes, Jordan, there's so many fun questions. And one question from Penelope is, what are some after-school activities you recommend to help find your career interest?
So what did I do after school? So funnily enough, I was actually an athlete through like middle and high school. So a lot of my after school activities were sports. And I think that is good for some things. Like there's a lot about sports medicine that I became interested in because I was doing sports, which is kind of how I got to the project with the knee. But I also did do some programs focused on like just overviews of science. And summer camps are also really good for this. So there was like a local summer camp in my town where you could like do chess in the morning and then do robotics in the afternoon and then do like coding before your parents picked you up. And we had a local university in my town. So they might bring in people from the university to talk to you about like the research they do. There was a period of time where I wanted to go into astrophysics because there was an astrophysicist who came and talked to me and it just sounded really cool. And I didn't end up doing that, but there are these careers that you don't necessarily hear about unless you can kind of get a plethora of people coming through and telling you about them. And I think right now is actually an interesting opportunity for stuff like that because I've been seeing a lot of seminar series geared towards like kids on different topics that you can just watch online, stuff like this, but also there are other similar online kind of virtual seminars that you can go to. So looking for stuff like that is something that I definitely recommend.
Awesome, thank you. Ava was wondering, what is your favorite organ to make?
Ooh, let's see. So a lot of what I did in lab was biomaterials based. So this isn't necessarily a favorite organ because my town had a summer program where you could work at, so I grew up in Montclair in Jersey. So Montclair State University had a summer program where you could go and do research in environmental engineering. And so that's what I did my first summer in high school. And then my next summer, I actually worked at Columbia in New York City. And there we got to do this method called electrospinning, which is where you like take a plastic in liquid form essentially, and you put it in a tube and then you put some sort of metal on the other side and you apply a charge to it. And you can create all these really interesting patterns because the plastic has a charge too. So you can design all these different materials by just like changing the configuration or like the charge that you run through either end. So that was what we used to design ligaments. Actually, we were looking at periodontal ligaments, which are the ligaments that keep your teeth in your mouth, and also the ligaments that tend to erode when you don't brush your teeth and get gingivitis. So that's probably the most fun technique that I got to do.
That is awesome. Another question from Angelina. What is your favorite thing about your job?
My favorite thing about my job, let's see. Grad school is always such an interesting job because you're like still in school and so you still feel like a student, but it's not quite the same as like K through 12 because you get to really run on your own schedule. So I guess my favorite thing is, and this will vary by like the lab you join and who you work with, but that my advisors are happy to kind of let me run with any interests I have, any trails that I kind of want to run down. If I have like an idea and I want to pursue it, they're very supportive in letting me do that. So like right now I have an idea for a device that I think would be very cool and useful to build. And because we're in quarantine, I can't actually build it because we can't order anything. But when we get back, they've both been very supportive in terms of like, okay, like what kinds of materials do you need? Like, is there someone else that we can reach out to who maybe has a background in this area that we can talk to get this off the ground? So I think definitely for me, I think grad school and kind of the thing that I didn't like about working in pharma was just having that like ownership of your project and really getting to like chase down whatever leads you want to find and learn the things that you have to learn. Like I didn't take physics, electricity, and magnetism in college. I took it in high school and then I skipped it in college. And so now I've had to relearn it because I need it to do the project. But yeah, really kind of getting to figure out what you want to discover.
We're having a lot of questions that are asking about grad school. And so a lot of them want to know, what is grad school like? And did you like grad school?
Yeah, so grad school, so I guess for anyone who doesn't know, so like after high school, you can go to college. College is 2 or 4 years, depending on what kind of degree you're getting. And then after college, you can go to grad school. And so there's a lot of different kinds of grad school. I specifically am in a PhD, which is a research degree. So I take some classes, but I spend most of my time doing research. And what research means, you know, depends a lot on what you're doing. But for me, it means doing a lot of coding, working on a specific project. And there's a comic somewhere that shows this, but it's essentially like there's a circle of like everything that humans know in this world. And my job as a PhD student is to push that circle a little bit wider. So it's not easy, but the challenge is very motivating. And anytime you like make a little dent, that the joy and the excitement that you get from that is really, really motivating to keep you on the rest of the project. So yeah, so grad school for me looks like mostly classes for the first couple of years. For the first 2 years, my program is a little bit unusual because it's joint between MIT, which is a school in Massachusetts, and Harvard Medical School. So half of the people in my program are actually training to become like actual medical doctors. And so we take medical school classes with them. So like I had to do an autopsy during my first semester, or we had to poke through a dead body, and that was really interesting. But yeah, it varies depending on what you do, but basically grad school is like trying to expand what we know as humans a little bit more and getting paid to do it.
Yeah.
Just a fun job.
Yeah, there you go. And another question from Penelope is, what has been your most influential and helpful college class?
College class. That's a good question. I think that, so there's a class that I took. So I went to Cornell for my undergrad, and biomedical engineering wasn't a major when I applied. It became a major when I got there. So we got to be the test run for all of the classes for that program, which was super interesting. Came with its highs and lows. But one of the classes that I really enjoyed was a circuits class. It was actually the first time that I had touched circuits since robotics in middle school. And the thing that I really liked about it, aside from it being a circuits class where you could actually touch the circuits yourself, was that it was very much based on active learning. So you're kind of given a goal, and you weren't necessarily given a ton of guidance on how to get there. Like you had all the tools, and the professor was there and the TAs were there if you needed help. But a lot of it was about like discovering how systems work, and then like learning the laws of physics that you just discovered after. So that was probably my most influential class, not in terms of what I necessarily learned in that class, but just in terms of like a learning style that really changed the way that I thought about research and education.
Awesome. Another question is, what exactly is astrophysics?
Oh, I still don't really know. I took that seminar, I was 16. Yeah, that's definitely a question for not me. It was just so interesting. They showed us like pictures of like stars in the sky and planets, and like we're trying to track how planets were moving and stuff, and it just seemed so cool.
Another thing is, did you ever consider becoming an ecologist?
So my first research experience was actually in environmental engineering and ecology. I didn't end up pursuing that after that research experience. That's actually interesting because I haven't thought about that in a while. I guess you could say that that's another example of like a research experience that I didn't particularly enjoy, not necessarily because the research wasn't interesting, but because of the circumstances surrounding the research. So yeah, I thought about it during that summer, but after that summer, it didn't seem particularly interesting. Part of it was essentially because the project that we were given was a project that another, I think, master's student or something had already done, and they didn't tell us that. So at some point we were like wandering around campus and we saw a poster on a wall and it was like the project and all the results. And we were like, oh, okay, cool.
Yes. Another question goes back to your K through 12 years, and it says, what kind of student were you K through 12 in college with undiagnosed ADHD? Did you struggle to stay focused, motivated, and get good grades? Just kind of how did that season of life go for you with that?
Yeah, so for a little bit of context, I got diagnosed with inattentive ADHD in January-ish of this year. And so it's something that I've spent most of my like educational life just not knowing about and kind of unconsciously managing. So in terms of grades, I guess, I was an, I guess, above average student in math and science, and solidly average in everything else. Anything that really required me to kind of sit down and focus for long periods of time, so English, history, stuff like that, didn't tend to capture my attention. And so I tended to do worse in those classes. But my math and physics classes, especially since I also just happen to have like good teachers, especially in high school, well, engaging teachers, wouldn't necessarily always say good, but I had teachers who kind of had teaching styles that forced me to stay on top of things. So one class that comes to mind in particular is like my physics class junior year, where the teacher would like have you watch a lecture and then put a problem on the board and throw a marker at somebody. And if the marker got thrown at you, that it was time to do the problem. So like that's an incentive. In terms of managing it, I don't know, it's hard to say, like, because I'm so recently diagnosed, I'm still learning all of the different ways that I've developed coping mechanisms to manage things. I think college actually helped a lot. Also things like technology. So like homework and whatnot used to get lost in my backpack all the time. And now I do everything on either my laptop or a tablet. So I can't lose it because it's not a paper that like goes to the bottom of my backpack. Yeah, hopefully that was helpful.
Yes. And there's a lot of questions about electives for middle school and high school. What are some electives would you recommend?
Yeah, I took, let's see, I think high school is easier. So I took a lot of like AP, and you don't have to take AP, it's just that that's what I was taking. But AP, like physics, chem, math classes. I took AP computer science because that was offered at my school, and that was definitely helpful. But at the same time, like especially pre-college, so at least for my undergrad, they don't assume that you know anything about engineering when you get there. So if you like don't take any engineering or any real math and science classes before you get to college, it's not actually that big of a deal because they'll just teach you all the things that you need to know. So I would say that the classes, the electives that I took that I guess were most interesting to me were things like music theory, because I didn't realize how much math went into it. Music theory was just something that I was weirdly good at because I was good at math. In middle school, we didn't really have electives in middle school, I guess. So it's a little bit harder to speak to that. Obviously, I did robotics, I did fencing, and then I did varsity fencing and tennis through high school. But yeah, I don't think like I was the student athlete essentially through high school and then became an engineer in college. So you definitely don't like have to take something to become interested in it later.
Another question said, did you ever fence competitively?
Yeah, in high school, and somewhat in college. I fenced for my high school team, and was captain, and we went to states my senior year, which was fun. And then I almost joined the varsity team when I went to college, but I was pre-med at the time. And the coach was worried that being a pre-med engineer would be too much of my time. And so I ended up joining the club instead and still kind of competed casually.
Nice. Who is someone that you admire today?
Ooh, that's a fun question. I feel like there are a lot of people that I admire for lots of different things. So I guess people that I admire, I mean, I think at the local level, like my friends, definitely. Like being at a PhD program is super interesting because see all of these people doing all of these amazing things in other fields that you know nothing about. And so I like, in particular right now, I have a lot of friends who are like doing coronavirus research and who are like figuring out like how this virus works and how we can develop a vaccine. And I'm like, that's crazy. Like you're like having way more influence on the world than I could ever imagine. So that's definitely one kind of like local spheres. I think, I guess looking for people who would be a bit more well known. I don't know if there are any famous people that I particularly admire. Like Adam Savage is like amazing because I grew up watching Mythbusters. But I also have found that as you get older, it's a little bit harder to put people on that kind of pedestal, as you just learn more about who they am as, or who they are as like people. So there are a lot of people who I admire for what they do. My first PI, my first advisor in high school, for letting a high school student who thought that doing research was doing Googling and then writing a report into her lab. But yeah, I think the people I really admire are kind of the people that I keep around me.
That's awesome. Let's see. What is your favorite thing to do?
Ooh. So in the lab, it's probably a tie between coding and building things. I also have to do animal work for my research. And I don't dislike animal work, but it's also not my favorite thing. But anytime I have to like brainstorm a new model, or if I get to like tinker around with our brain simulator or something, that's probably my favorite thing to do in the lab. Outside the lab, it would probably be a tie between lifting. I do a lot of weightlifting and reading. So I'm still very into reading, mostly sci-fi.
Another question said, did you ever consider going to a college without a football team or school pride? Do you think it's important in choosing the right college?
Oh, I didn't choose, I guess, sports or like large sports, because like fencing is not a sport that like anyone's showing up to cheer for. Yeah, I didn't consider sports when I applied to schools. I was mostly looking at their engineering programs. So Cornell's football team sucks badly. So clearly I was okay with that. Yeah, I mean, I guess I didn't explicitly consider it when I was thinking about applying to college in the first place. It wasn't something that really bothered me. Cornell does have a lot of school pride around hockey. I mean, that's something that I've kept since graduating. I still very much enjoy watching hockey. Try to get down to the Cornell Harvard games when they're up in Massachusetts. So that's something that I've definitely kept. Oop, you're muted.
Thank you. A question from Jasmine said, did you know what you wanted to do in the future when you were in high school? If you did you tailor your schedule to fit classes that were related to that career field?
So I knew that it was probably going to be something related to medicine and maybe something related to engineering. And then towards the end of high school, I knew that it was going to be something related to engineering and maybe something related to medicine. So those were kind of the two topics that were always in the back of my mind. I wouldn't say I tailored my schedule too much to fit those things, aside from like making sure that I took the classes that the schools that I was applying to like required you to have taken by the time that you were applying. I think high school for me was really, it was about like taking classes that I was interested in, but we didn't have like medicine classes. So like I took a lot of French because I really wanted to learn French. Or I took a lot of harder math and science classes because I wanted to learn more math and science. But like I don't think I took biology at all. Or no, I think I had to take 1 year of biology because like New Jersey requires it. But yeah, I took hard classes in the fields that I enjoyed and didn't pay too much attention to whether or not they catered towards any particular field.
There's a question earlier from Ava that says, how do you make superhero in a lab?
Oh, that's fun. Yeah, so this is from a class that I taught. So there's a program called Splash and multiple universities run it. It's a couple, usually I think 2 or 3 days, where anyone who's affiliated with those schools can teach a class on whatever they want. And so I, in high school, did Splash at MIT for 2 years and took like a bunch of random classes. Like I learned how to make chainmail. I took like an intro to Russian. I learned about the chemistry of explosives. And so when I got to Cornell, they just started up a Splash program, and one of my friends was running it and needed people to teach. So that's how I got roped into that. And there's, a lot of different ways. So the goal of the class is basically to talk about the different kind of subfields of biomedical engineering and bioengineering more broadly, and use those to pick different superheroes and figure out how you kind of engineer their powers. So one particular favorite of mine is Mystique from X-Men, because there's like a bit of a conundrum in the fact that she can like physically change her size, and so in doing so there has to be some like gain or loss of significant energy, and like how do you do that without like accidentally setting yourself on fire if you're like trying to go from being adult to being a kid? How does that work? And so there are a lot of interesting theories that I heard about that. I think one of them was that her skin was blue because, kind of similar to like chloroplasts in plants, she used it to like absorb energy and like store it. And so she was becoming like smaller. She could just absorb that energy and store it until she wanted to become bigger again. So stuff like that. Those are kind of the things that we talked about in terms of engineering superheroes.
Matthew asked, could you make SpiderMan?
We also talked about SpiderMan. There is I think it's a spider. Well, so there are two approaches that people often came up with. There was one basically like taking the apparatus that makes and shoots web from a spider and just like putting it in your arm. And the other one is finding a way to use some sort of kind of like electrospinning, actually, finding a way to like embed polymers into your arms that your body can ideally like replenish in some way, and then shooting that out of your arm. So in theory, yes. Would anyone let us try that on them? Probably not.
Right. Another question is, what is your favorite hobby?
My favorite hobby, I guess in theory it's YouTube, but monetizing your hobbies makes them work. So past YouTube, it's probably fitness.
Can you tell us more about your YouTube channel and kind of what you do there?
Yeah, so I started my YouTube channel right before I started grad school, which is a great time to put more things on your plate. And it's a channel broadly about the ways that we interact with artificial intelligence and algorithms more broadly on a day-to-day basis. So that's anything from things like facial recognition to more kind of fun and silly things. Like I did a video where I had an algorithm generate like Valentine's based on Valentine's Day cards. I made a recipe that was generated by an algorithm. It turned out quite bad, but it was very funny. Yeah, stuff like that. I have a video about like how to make neural networks using like dominoes, so that you can kind of see how the networks work together. So yeah, it's not necessarily a technical channel. I do like occasional videos in a series that I call AI 101, which focuses on like actually learning how to code. But most of them are like when you know, walk down the street and you see a camera, like, does that camera know who you are? Like, stuff like that.
Jordan, what's your favorite algorithm?
My favorite algorithm? Right now, it's probably, this doesn't necessarily count as an algorithm, it's more of a process, but it's this thing called Bayesian optimization. And what it essentially is you are trying to monitor something and adjust it to the point where you reach some goal. And so you basically try something random and you see what happens. And then you update your algorithm. And then you try something kind of random, but also informed by what you just tried. And then you see if it works and you update your algorithm and you keep doing that until you hit the target. And it's a super interesting way of doing things like brain stimulation, because you might be able to either, if you're looking for like some sort of behavior coming out of someone, then you might be able to just keep doing that until you see that behavior, and that's how you find the optimal stimulation. Or you can use it for studying different things. So yeah, I've been doing a little bit of reading on that lately.
Someone asked who created this algorithm.
No idea. It's been around for a very long time. Probably some guy in the 1950s. But yeah, I don't actually know off the top of my head. It's been around for a while.
Another question is said, could cameras catch DNA and read it if it's dead DNA cells?
If you had a camera that could see up that close, then maybe. We don't have those cameras yet.
Cool. Another question said, did you get any scholarships and how?
So for undergrad, I did not. Grad school is paid for in some way. How it's paid for depends a lot. So some people have to teach and that's how they get paid. Some people have like specific research projects and that's how they get paid. And then there are things like fellowships, which are basically scholarships, but for grad school. And so I have a fellowship. I actually have 2 fellowships. And the fellowships, yeah, I mean, if you Google like STEM grad school fellowships, then you'll probably find them. I have one called the Graduate Research Fellowship, which is through the National Science Foundation. I also have one called the GEM Fellowship, which is for minorities, and I can't remember what GEM stands for. But yeah, they funded me for my first year, and then the NSF funds me for the next 3 years. And then my labs have money, so they will fund me or I will apply for something else after.
Awesome. Another question, have you considered cloning?
I personally, no. That's something that always comes up in that splash class that I teach, actually, where it's like, well, why don't we just build another person, and then whenever I need an organ, we can just take it from that person. There's lots of ethical quandaries that start coming up when you start doing things like that. But for my work, it's not particularly useful, and it's not, you know, something that I necessarily see us doing in like people anytime soon because of a lot of the ethics issues. Also because of the science issues, but mostly because of the ethics issues.
Right. Jessica asked, what was your favorite subject in school?
It was math pretty much until college. And then after or in college, it became anything like lab based. So anything where I could like build things.
Another question said, what specific skills must you have for your job?
That's an interesting question. So grad school, this will depend a little bit on like where you go. But for my program, we can work at any lab in Boston, basically. So it's not like assumed that you come in with any specific set of skills. So I didn't work with animals before I started grad school, and I work in neuroscience. So I also had no background in neuroscience. And a lot of it, like the main skill is that you've ideally done research before, and so you kind of understand the research process, even if you don't understand the specific things that you're going to be doing. And just like enthusiasm and a willingness to learn. Like I reached out to both of my advisors beforehand and was pretty upfront with like, here's what I'm good at. A lot of that is not the stuff that you do, but I'm interested in the stuff that you do, and I want to see how I can like overlap these two things together, and they were totally fine with it.
That's awesome. Alexander asked a great question, said, do you work with machine learning algorithms in biotechnology? If so, what is your most used type of learning within AI? Classification, unsupervised learning, etc.
So it would probably be a tie between supervised learning and dimensionality reduction. Neuroscience, you can measure so many things, and you do measure so many things simultaneously that it is difficult to process all of that data without doing some sort of downscaling, so that you can pull kind of the useful stuff out of that data. And then I guess I would really call it like semi-supervised learning, because the interesting thing about a lot of neuroscience data is that the labeling is like very much dependent on who labeled it. So what I think is like, for example, if I'm looking at a bunch of like EEG recordings, which is like recording the electrical patterns in your brain, and I say that like this region is sleep, like someone else might not agree with me. So it gets a little bit dicey in there. So yeah, probably I don't do a ton of unsupervised learning. And then control systems and reinforcement learning are something that I'm getting more into as we get to like device control and stuff.
Awesome. Another question is, have you ever considered using mushroom roots for packaging?
No, I have not.
There you go. Another question says, does computer science require 100% of yourself and time?
No. I would say that a lot of like project and grad school questions really depend on the people you work with. And that also applies to like jobs that aren't grad school. But like, I know for me, my advisor, if we're like in the office past like 6 o'clock, then he like comes in and he's like, go home, like get out, have work-life balance. So I would say it doesn't consume all my time. I do a ton of things outside of lab and YouTube. And I have only recently started to have a little bit of trouble balancing it, but that's because I'm working with some of the like institute level coronavirus reopening stuff, which has just been taking lots of time. But I think if you're in a lab with an advisor who like values your time and wants you to like treat this like a job, essentially like have a 9 to 5 schedule, then like it's not going to take 100% of your time. I would say it takes slightly more time than the time I spend in lab, just because it's a field that I find interesting, and so I spend a lot of time reading about it.
Matthew has a question about SpiderMan again. It says, could you recreate the SpiderMan bioweapon prototype from the movie that changed everybody into a lizard?
I don't know if I know what movie that is. The answer to a lot of like, could you take sci-fi thing and make it into a real thing is like, maybe, but it depends on what assumptions that like the sci-fi movie itself is making. Yeah, I think that's my best answer.
That's great. Another question is, what are some of your favorite sci-fi books?
Ooh, So a lot of the stuff that I'm reading right now is like not something that I would recommend for people in high school or younger. in the sense, it's like stuff like The Magicians, A Darker Shade of Magic, a lot of like V. Schwab books that are super interesting, but they're definitely geared towards like people in their like early 20s.
Right. Another question is, as we delve into a better understanding of deep feed AI, do you think utilizing neural networks for artificial brain repair is likely?
Not in the short term. We don't understand enough about the brain to, we both don't understand enough about the brain and don't understand enough about neural networks to like use one to solve the other is the answer to that question. And there's a whole debate in the field on, you know, modeling something you don't understand with something you don't understand and whether or not that is a useful exercise. I think it is, but I also think that a lot of what we're trying to understand relies on a much better understanding of the brain that we don't necessarily fully have yet.
Yeah. A good question too is, what is artificial intelligence?
Yeah, so I've been using them as somewhat interchangeable terms, and they're not really. Basically, artificial intelligence is any program that aims to replicate human intelligence. And it's a very interesting term because it also assumes that we have a great understanding of human intelligence, which we don't. Machine learning is a subset of algorithms that find usually statistical patterns in data, and then use those patterns to predict on new data. So you can use machine learning for AI tasks, but they're not necessarily, you know, there's a Venn diagram and there is overlap, but they're not the same circle.
Mm-hmm. Another one is it essential?
How is AI essential?
Yeah, how is essential?
I mean, I hesitate to say that anything is essential. I think that there's a lot of good uses for it in terms of like workflow and pipeline management. But there's also a good number of kinks to be worked out in terms of mostly fairness and bias issues. So I think, yeah, I don't know if there's a circumstance where I would ever say that like AI is an essential thing. But I think that there are pros of using it over other systems, and most of them have to do with processing large amounts of data relatively quickly, and expediting processes that otherwise are prohibitively long.
One question is, what was your favorite book growing up?
Ooh, growing up, I read Ready Player One several times. Let's see. I was very into like the stereotypical young adult fiction in like high school and middle school, so a lot of stuff like that. Things like City of Bones, like Mortal Instruments series and stuff like that. Yeah, those are the ones that come to mind off the top of my head. I feel like I have a lot more books now that I've like read several times than I did when I was growing up.
Right. Okay, so let's just round out one more question. How do you do school and then stay connected during this quarantine time? How does that look like in this season?
Yeah, so it's been interesting. I've been in quarantine since, I guess it's been what, like 4 months now? Yeah, and a couple things help in terms of like work. So because half of my work is animal work, but the other half is computational, a lot of things I can just do from home. I don't do any of the like serious machine learning work on my laptop. I do it, I access a remote computer that lets us run things just a lot faster. And so I can do that from like anywhere. It doesn't need to be in lab. But we've also, I think, been entertaining ideas that we might not have had time for beforehand. So like this new device that I was talking about is something that like just wasn't something that I had time to look into. And now I do. So stuff like that. And then outside of work, we've been doing, my friends, people in my cohort, stuff like that, have been doing a lot of like, a lot more time spent in Slack, talking to people in Slack. And that also applies to, there's like my friends, my like lab people, and then like I have an agency that manages my YouTube channel, and so I have a lot of friends in that group. So there's been like a lot more YouTube collabs, which has been fun. There's been a lot more like virtual hangouts, where we'll all kind of get on a Zoom session together and just like talk at like some regular time during the week. There's been some socially distanced walks. Yeah, a lot of it definitely relies on like Zoom, texting, like group chats and things like that, which is definitely not ideal. But our labs actually started opening up yesterday, or not yesterday, last week. So we are also starting to see people in person again, which is cool.
Good. I celebrate that with you. I'm very thankful that you get to do that. And I know that probably feels good. And these are really wonderful questions, everyone. And we just are really thankful for Jordan. Ava, do you have anything for us?
No, I don't, but I hope you all enjoyed this Brain Candy Lab session. From building organs to zapping brains, my nonlinear path through science with Jordan Harrod. There's a question about what Brain Candy Labs is, and I wanted to answer it for you. Brain Candy Labs is an opportunity for us kids to get curious and learn from role models. Just like today, you can read more on our site and our community at www.braincandylabs.com or follow us on Instagram at BrainCandyLabs. We love your feedback, so please go to the chat and see our survey link. Our next question is at 10 a.m. with the world's youngest astronaut in training, Alyssa Carson. I hope to see you there. Until next time, this is Ava Astro for Brain Candy Labs, reminding you to stay curious and don't forget to ask the next best question.